Yes, ma'am. Bismillahirrahmanirrahim. Rabbi zidni ilma. Quote of the day. People come into your life either as a blessing or a lesson. There is benefit in both. Take the blessings and learn the lessons. Assalamu alaikum. My name is Dr. Sadia Rafiq, and today my topic of presentation is Anova and Cascade tests. My presentation includes a detailed discussion regarding statistical tests, including Anova and Cascade test. And at the end of this presentation, my colleagues would be able to describe Anova and Cascade tests. Starting with the Anova. Introduction. The analysis of variance is developed by R.A. Fisher in 1920. If the number of the sample is more than 2, then z-test and t-test cannot be used. The technique of variance analysis developed by Fisher is very useful in very such case, and with its help it is possible to study the significance of difference of mean values of large number of sample at the same time. The variance analysis studies the significance of the difference in means by analyzing variance. The variance would differ only when the means are significantly different. The techniques of the analysis of variance as developed by Fisher is capable of fruitful application in a variety of problems. Null hypothesis is variability within groups is equal to variability between groups. And the alternative hypothesis is variability within group does not equal to variability between groups. F statistics. Anova measures two sources of variations in the data and compares their relative size. Variation between groups. For each data value, look at the difference between its group mean and the overall mean. And variation within groups. For each data value, we look at the difference between that value and the mean of its group. So you can see the variance within group, the difference between group means, and it is the difference between group means. This is within groups and this is between the groups. The ANOVA F statistics is a ratio of the between groups variation divided by within group variation. Its formula is F is equal to MSC divided by MSC. The MSC is between the groups divided by the variation within the sample. A large F is evidence against the null hypothesis, since it indicates that there is more difference between groups than within groups. Assumptions in ANOVA analysis. The samples are independently drawn. The population are normally distributed with common variance. They occur at random and independent of each other in the groups. The effect of various components are additive. So the null hypothesis is that the means are all equal. So mu1 is equal to mu2 is equal to mu3 and mu2. The alternative hypothesis is that at least one of the mean is different. This can be best explained by the example. The statistics classroom is divided into 3 rows: front, middle, and back. The instructor noticed that the further the students were from him, the more likely they were to miss class or use an instant messenger during message. He wanted to see if the students further away did worse on the exams. The ANOVA does not test that one mean is less than another, only whether they are all equal or at least one is different. So it was the null hypothesis. Mu of front and middle and back benches are equal. A random sample of the students in each row was taken. The score for those students on the second exam was recorded, and it was like that of the front, it was the middle and back. These were the scores. The summary statistics for the grades of each row are shown in the table below. So these are the rows, front, middle, back. The sample size for the front was 7, 9, and 8. And the mean for front, middle, and back. Then the standard deviation, and then the variance of all this. And variation is the sum of the squares of the deviation between a value and the mean of the value. Sum of square is abbreviated by SS and often followed by a variable in parentheses such as SS between and W for within the groups. So we know which sum of the squares we are talking about. Are all of the values identical? No. So there is some variation in the data. This is called the total variation, denoted as total for the total sum of squares. Variation. Sum of squares is another name for variation. There are two sources of variation. The variation between the groups or the variation due to the factor, and the variation within the groups SSW, or the variation that cannot be explained by the factor, so it is called the error variation, which is within the group. Grand mean. The grand mean is the average of all the values when the factor is ignored. It is weighted average of the individual sample means. It is the formula for the grand mean summation of the and the values. And when we open this formula, it is written like this for each sample size. So by putting all those values in our example, grand mean of our example is 65.8. We just added up all the means and then divided by the number of the sample, we got this, and our grand mean is 65.08. Now, between group variation SSB, it's its formula, summation n x minus x double bar square. And then after in this formula, the between groups variation, for example, is 1902. So by adding all these means and everything, at the end we have this figure. And again, we have the formula with within group variation, which is SSW. And now again, we will put in values in it. The within group variation example is, after calculation, is 3386. So we will draw a table. The source SS, sum of squares, which was between 1902, within was 3386, and the total is 5288. Now moving forward. The degree of freedom. A degree of freedom occurs for each value that can vary before the rest of the values are predetermined. The degree of freedom is often one less than the number of the values. The between group difference degree of freedom is one less than the number of groups. We have three groups, so it is 2. 3 minus 1 is 2. The within group degree of freedom is the sum of individuals of each group. So we will add within the group 6, 8, 7, it is 21. And the total degree of freedom is one less than the sample size, and 24 minus 1 is 23. So in the next column, we will add the degree of freedom between, within, and then again the total. Now, what is MS? MS is the mean square, and it is obtained by the division of SS and the sum of squares divided by the degree of freedom. And for each one, we will calculate it. 1902 divided by 2 is 951, then 3386 divided by 2161, and then the total. Variation divided by degree of freedom. F-test statistics. An F-test statistics is a ratio of two sample variances. The MSB and between and within are two sample variances, and that's why we divide to find the F, mean squares. After the division of the mean squares, we find the value of MS. So we have this value from the data, and after putting the values, we get F value 5.9. The F-test is a right-tail test. The F-test statistics has an F distribution where degree of freedom between numerator of difference and within denominator DF. The p-value is the area to the right of the test statistics, with the value at this is 0.009. So adding this value, degree of freedom, and the p-value at this point is 0.009. The p-value which is less than the significance level of about 0.05, we reject the null hypothesis. There is enough evidence to support the claim that there is a difference in the mean scores of the front, middle, and back rows in the class. The p-value is 0.009, which is less than the significance level of 0. So we reject the null hypothesis. The null hypothesis is that the means of the three rows in class were the same, but we reject that so that at least one row has a different mean. There is enough evidence to support the claim that there is a difference in the mean scores of the front, middle, and back rows in class. The Anova does not tell which row is different. You would need to look at the confidence intervals or run post hoc tests to determine that. I'm finishing my ANOVA test over here. Now moving towards the chi-square test. Chi-square distribution, first formulated by Frederick Robert Helmont in 1843 to 1917, developed by Carl Pearson Layton in 1900. It is the simplest and most widely used statistical test. Why? It is used to test the number one independence of attributes and goodness of the fitness of the distribution. It is used to estimate the statistical significance of population variance, parametric cascade tests. And when it is used, mostly used for discrete data, sample observations are independent of each other, constraints on cell frequency should be linear, total frequency should be greater than 50, the frequency in each cell should not be less than 5. If one of the cell frequencies is less than 5, it is mandatory to apply Ziette's correction. And how it works, first of all, define null hypothesis and alternative hypothesis, then obtain expected frequencies. Compute the values of chi-square test statistics, find out degree of freedom, obtain table value of chi-square, compare calculated chi-square with tabulated chi-square, and then we state and interpret the result. Either we reject or accept the null hypothesis. So, where hypothesis testing, it is used to test a claim about the parameter using evidence, data in the sample and their association. The random sample summarizing the information. Does the given information support the hypothesis? Are we making any error? Then the decision rule. Convert the research question to null and alternative hypothesis. Assumption mates are include the random sample data, a sufficiently large sample size, adequate cell sizes, independent observations, non-direction hypothesis, and observations grouped in categories. Chi-square distribution. No negative value in it. Mean is equal to degree of freedom. Standard deviation increases as degree of freedom increases. As the degree of freedom becomes very large, the shape becomes very likely to the normal distribution. As you can see in it, the shape of the curve changes as the degree of freedom increases. At degree of freedom 3, it is like this. At 5, it is, and at 10, it is just look like the normal distribution curve. So as the degree of the freedom increases, it requires the shape of the normal distribution curve. Degree of freedom. It denotes the number of classes to which value can be arbitrarily assigned without breaching the imposed limitations. It has two formulae we can use like this, where the degree of freedom is equal to n minus k, where n is the sample size and k is the number of the independent constraints, or degree of freedom columns minus 1 and rows minus 1. These are two formulae by which we can find out the degree of freedom. This is the chi-square table. It gives distribution of the values of the chi-square over a range of degree of freedom and for different levels of significance. As you can see, it is the degree of freedom. This is the probability values. Till here, these are non-significant values, and above this, these are the significant values. Critical value is the point which demarcates the acceptance region and the rejection region. It is the critical value. Here we have to accept the null hypothesis. The area to the right, the critical value is the rejection region, and area to the left is the acceptance region. Chi-square test of variance, used for estimating the statistical significance of population variance. Examines if a sample comes from a normal distribution with specified variance or a different variance. Only applicable for samples drawn from populations that follow the normal distribution. This is the formula where A2S is sample variance, Sample variance divided by the population variance, and n is the sample size. So it is a formula for the chi-square. Steps are: state the null and alternative hypothesis, calculate chi-square value using the formula, compare the calculated value of chi-square with the tabulated value of the chi-square, which I have shown you previously. Non-parametric chi-square tests. These include the chi-square goodness of a test, Pearson's chi-square test of independence, and chi-square for homogeneity. Characteristics. It is positively skewed. It is non-negative. It is based on degree of freedom. When the degree of freedom changes, a new distribution is created. Variance equals 2 times the number of degree of freedom. Goodness of a test. It investigates the conformity of empirical distribution with hypothesized theoretical distribution. It investigates conformity by comparing observed and expected frequency count. So in it, we see the frequency. Like this in the example, calculate chi-square from given table and conclude whether there is an association between addiction of alcohol or liver cirrhosis. So we can say the addiction of alcohol, no addiction, drinking once in a month, more than 2 and 6 to 8 months. So liver cirrhosis present or absent. So these are the different. In non-addiction, the liver cirrhosis present, absent, the total is like this. And then by all, we add them and it is like that. The Pearson's chi-square test of independence. Test the null hypothesis that the rows and columns classification factors are independent. Determine presence or absence of association between two attributes. Does not measure the extent of association between attributes. So this can be seen. We are concerned with all the columns and rows. Following table shows birth order of the child and congenital malformation seen. Comments whether there is any association between birth orders and occurrence of congenital malformations. In this, we have the birth orders, then the babies with congenital malformations, their number, then the babies without malformations, their number, and then the total. So we test the null hypothesis that the rows and column classification factors are independent. Then the Cascade test of homogeneity determines whether two or more independent samples are drawn from the same populations or from different populations. Its example, a study was carried out on the relationship between migraine headaches in 96 subjects diagnosed with narcolepsy and 96 healthy controls. The results are shown in the table. We wish to know if we may conclude on the basis of these data, conclude that the narcolepsy population and healthy population represented by the samples are not homogeneous with respect to migraine frequency. So in this table, frequency of migraine headaches by narcolepsy status, NS narcoleptic subjects and healthy controls, and the reported migraines, yes and no. And by this we will calculate it. What is the difference between the chi-square test of independence and homogeneity? It tests the presence and absence of association between attributes. It tests whether two or more independent samples are drawn from the same population or not. It involves a single sample drawn from the one population, and it involves two or more samples perhaps drawn from the same or different population. Chi-square for a 2 by 2 table. Contingency table is a two-way table with 2 rows and 2 columns used to depict relationship between two attributes. So we have variable 1 or control, variable 2 or a case, present, absent, yes, no. It is the way we add up the things. These are the marginal totals and n is the grand total by adding all of them, rows and columns. It is the formula of the chi-square. It is the observed value, it is the expected value, and I is the 1 to 3 number. Alternative formula is like this by adding all the columns and rows. N is equal to A plus B plus C plus D. Example, researchers wanted to determine the impact of fall of lifestyle changes among polio survivors. Table shows a result of the study of 233 polio survivors on whether fears of falling resulted in lifestyle changes. So in this way, we will draw a 2 by 2 table while fallers and non-fallers, the made lifestyle changes because of fear of falling, yes or no. And then we will have positive and negative. We will add the columns and rows. And after adding all the time, we have N, 233 of the total number of the patients on which the study was conducted. Yet is correction. Need. If the expected self frequencies are below 5, if a 2 by 2 contingency table is being used. Effect. This reduces chi-square value obtained and thus increases p-value. It prevents overestimation of statistical significance from small data. It is the formula for the Yeti's correction, where OI is an observed frequency, EI is the expected frequency asserted by the null hypothesis, and N is the number of distinct events. Limitations. Yeti's correction may tend to overcorrect, fails to reject the null hypothesis when it should, and its uses are used when at least one cell of 2 by 2 contingency table has an expected frequency less than 5. Example is Turner surgical site infection after coronary artery bypass TAP surgery is a complication. A study was carried out examined two types of preoperative skin preparations before performing open heart surgery. These two preparations should use aqueous iodine and insoluble iodine with the following result. So you can see the preparation group, aqueous iodine, insoluble, infected, non-infected is a comparison of aqueous or insoluble preparation. So infected, non-infected, total of 108 patients have aqueous iodine and total 101 have insoluble iodine. And these are the results. And in this, you can see, or this one is less than 5. Its value is 4. So here we will use the Yeti's correction. Advantages of chi-square test. The additive property of chi-square. The sum of chi-square values have x-square distribution with degree of freedom equal to the sum of degree of freedom of individual chi-square values. Summation of values is suitable only if the samples are independent. Additive property is valid only for uncorrected chi-square values. Limitations of chi-square test. The chi-square test does not give us much information about the strength of the relationship. It only conveys the existence or non-existence of the relationships between the variable investigated. The chi-square test is sensitive to sample size. The chi-square test is also sensitive to small expected frequencies. It can be used only when not more than 20 of the cells have an expected frequency or less than 5. Cannot be used when samples are related or matched. Chi-square test is not valid for proportions. Fisher exact test. Why? Chi-square test cannot be used when sample size is very small. If any of the expected frequencies is less than 1, if more than 20% of the expected frequencies are less than 5. Determine the probability due to chance of an association between two characteristics being analyzed. And it is the probability, it's this formula. Example, the number of the boys and girls who are regular in the physical exercise is distributed as given below. So when we said boys and girls exercise regularly not, in this we said it is less than 5 and it is less than 5. So this is the references of our presentation. Now moving towards the multiple choice questions. The analysis of variance is a statistical method of comparing of the cell population is mean, standard deviation, variance, and mode.
Means.
Yes, the correct answer is mean. What is the function of post-tested ANOVA? Describe those groups that have a reliable difference between group means. Set the
A.
yes, you're right. Describe those groups that have reliable difference between group means. Between. If the true means of the K population are equal, then MSTR, which is treatment mean square, is divided by error mean square, should be equal to close to 1, close to -1, a negative value between 0 to -1, or more than 1.
A.
Yes, you're right, it's A. To determine whether the test statistics of Anova is statistically significant, it can be compared to the critical value. What two pieces of information are required to find out critical value? MSTR, MSC, mean sample standard deviation, expected frequency, obtained frequency, sample size, or the number of groups.
A.
No, it's D. Sample size and number of groups. So as we know, we are dealing with the ANOVA. Variance numbers depends upon the number of sample sizes and the groups. Because we have to say within group variation and the between the group variations. The error deviates within the SSE, error sum of square statistics measure distance between groups, within groups, none of the groups, both A and B. It's
Within
the,
groups.
yes, within groups. The correct answer is because with the error sum of squares, we find within the groups. Which chi-square distribution looks like normal distribution? The chi-square
D.
distribution, yes, 16 is degree of freedom. As I've told you, as the degree of freedom increases, the curve becomes just like similar to the normal distribution curve. So the degree of freedom in this scenario, 4, 5, 6, and 16, 16 is the maximum degree of freedom and would look like normal distribution. The variance of chi-square distribution is given as K, true or false?
False.
How and why? I tell you. Anything do you want to say, sir? Okay. The mean of the chi-square distribution is given as K, and the variance of chi-square distribution is given as 2K. So this is false statement. Which of these distribution is used for testing hypothesis? Normal, chi-square, gamma, or Poisson?
Normal.
No. It is the chi-square distribution because after calculating the chi-square value, we are in the hypothesis testing, we reject or accept the null hypothesis. So it is the chi-square distribution. On which of the following does the critical value of chi-square rely? Degree of freedom, sum of frequencies, rows total, number of variables.
Degree of freedom.
Yes, the answer is degree of the freedom. Using a goodness of fit test, we assess whether a set of obtained frequency differ from the set of dash frequencies. Mean, actual, predicted, or expected.
Expected.
Yes, the correct answer is expected. This is the key. Thank you so much.
Thank you very much, Dr. Sadia. It is a wonderful presentation. Anova and chi-square both are a useful tool while we are dealing with biostatistics, and they come very often in our daily practice. And it is a very good presentation. And especially the MCQ part, I really appreciate that a lot of hard work has been put in, and it is made so easy that most of the concepts are so easy to understand that everyone can now apply it practically. I want more and more of practical exercises later on so that everyone can apply the chi-square test as well as ANOVA on their data sets and on their research after collection of data. Thank you very much. If the class has any question, you are most welcome to ask, please. Okay,
Thank you,
thank
ma'am.
you very much. Allah Hafiz.